Welcome students, the video lectures of our calculus playlist. It is the fourth video I made. In the last video we have seen how to compute the area under a curve or a plane region with the help of that definite integral. In the same way, we are going to use that single integral to compute the volume of a solid by disk method. So this method is famously known by that disk method. What is the central idea behind this? So consider a sketch Let us consider a curve. This is the square root function. Y is equal to square root of x, or we can write x power half without radical. We have taken a square root function. We have to find out the volume of this solid. How the solid is formed here? We need to rotate that curve about the x-axis. It is called the axis of rotation. Axis of rotation, or we can say revolution. This arrow indicates we are rotating that curve either clockwise direction or anti-clockwise direction, doesn't matter. So what is that we are going to get? We are going to get a shape like this. Just I took the reflection of the curve. If I consider the portion from 0 to some value a comma 0 on the x-axis, so we are going to get a solid generated as shown here. Simply speaking, it is a cup-shaped solid. The origin, and this is the point A where it is going to zero to A, x equal to 0, x equal to A. We have to find out the air content or the fluid content inside this solid. How much air it can hold or how much fluid it can hold is called capacity. We need to find the volume of this shape solid formed by rotating this curve y is equal to root x about the x-axis either clockwise or anti-clockwise. The curve portion is taken from 0 to A. 0 to A. Generally, this one, whatever you find right side of y, we can take it as r of x for time being. In some textbooks, they will take f of x by default. This r of x, nothing but radius. Radius of the solid. R of x or f of x. So what we will do, we will slice that solid so that the radius will be perpendicular to the axis of rotation. This is r of x. You see this square symbol indicates the angle between the axis and the radius will be perpendicular. It is your axis. This is a care for disk method. If you make slices, means the radius The slicing direction should be along the radius. It should be perpendicular to the axis of rotation. Thin slices, like chips, if you make slices, let us take a small slice. Consider a thin slice of the solid. This solid, the thin slice will be like this. It is magnified one to get clarity. Generally, you can imagine the slice can be a compact disc where you can't see the hole at the center. Compact disc. What you get if you pile up the discs of same nature from down to top, from head, we get a solid. What is happening there? The area of the disc, if you multiply with the height, we get the volume of the solid. Here generally this slice, it is from A or 0 to A. Whatever the part you take, you can take the big slice or small slice, thin slice. So because this is the radius, it is 90. This is your R of X, radius. Because the base is a circle, it is the base. Base of the slice is a circle. And this vertical line, the horizontal line, this one is the thickness. Small thickness. We have to take that slice with the uniform thickness along the x direction dx. We know the thickness dx. Overall, this is a cylinder. The thin slice, whatever you took from that solid, it is a cylinder. Moreover, it is circular cylinder. So how to get the volume of the thin slice? This thin slice is very easy to understand. I hope that figure is clear to you. Is a solid form. I am taking a slice of it whose thickness is dx, very small change in x, because we are rotating about the x-axis. So we have to, axis is the x-axis, we are cutting the solid vertically along the x direction. That's why thickness is the dx. Here in cylindrical sense, it is called small height. Small height you can write, because for cylinder we require height and radius base. Let us see how to compute the volume of this thin slice taken inside the solid. So dA, this stands for small area of the base of the slice, thin slice, whatever you took. So area is given by the circle. Base is circle. Base is circle. As I mentioned in the previous figure, circle. So pi into radius square. Because it's area, we can write unit square. Units. That's nothing but pi. Radius we have taken as R of X. dV means small volume. small volume of the slice. A slice in the case cylinder, circular cylinder. How to get the volume of a cylinder? It is area of the base into unit height into height of cylinder. Continuation. So dV, area of the base, just now we have taken dA, and here for height we can take thickness dx. Because volume, the units are in cubes, unit cube. This will be dA is equal to pi into r of x square, thickness dx. So by adding up of that small disk what I have chosen from starting x equal to 0 to x equal to a, we get the complete volume of solid. Because small disk to big disk, we are going to add up, we get the complete solid. That's why it's called disk method. So integrating from x equal to 0 to x equal to a, both sides, pi is a constant, 0 to a, r of x square dx. By adding from a to b the small slices, we are going to get v, volume of solid v, 0 to a, r of x square dx, unit cube. Because r of x is clear to you from the given graph, we can substitute there. Hope this is clear to you regarding small area and small volume. By compiling or by adding all small slice areas, we are going to get up to this height 0 to a, we get the total volume of the solid formed. So on substituting that radius pi outside is 0 to a, it is root x whole square dx. It is very easy to compute. Pi between 0 to a x dx, that is pi, the integration is x square over 2, 0 to a. On applying the limits of integration, we get the required volume of the solid. It is a square by 2 minus 0 square by 2, which is equal to pi by 2 a square, unit cube. So in disk method, we have to take the slicing is to be done vertically or perpendicularly to the axis of rotation. You can take the slice along parallel to y-axis or parallel to x-axis. If you take the slicing parallel to x-axis or y-axis, dx will be thickness. We move along x direction. If you take the slicing horizontally, we have to move along y direction. So simply the formula to remember this method along x direction is v is given by from starting value a to b, pi outside, radius square dx, unit cube. Similarly, it is here r of x is perpendicular to x axis. Be careful. Number one. Second formula, we can take pi outside C to D. C to D. Here we write R of y square dy unit cube. This here the radius R of y is right angle to y axis. Sizing is done horizontally. So depends upon the figure, you need to choose first formula or second formula to get the volume of the solid of revolution. It is also called solid of revolution because the solid is found by rotating the curve either clockwise or anti-clockwise over a vertical plane or horizontal plane. Because we are getting discs from starting value to last value, wherever the curve is going to end, the method is called disc method. In disc method, we get circular cylinders. Circular cylinders. The slicing is to be done perpendicular to the axis of rotation. In next video, we are going to cover washer method. Washer method is also called do nut method. Just quite opposite. There we are going to take two different curves or concentric curves. The same way we can able to do it to get the volume of the solid. In next video we are going to see washer method. Hope this video is clear to you, and share these videos with your friends so that they also get the information. What is the concept behind the volume to find the volume of solids using single integrals or line integrals? Do share our channel, subscribe, post your comments regarding doubts. All the best.